one solve for now. I'm sure we'll have other references on, but we'll give it a shot for at least right now. All right, fantastic. So let's think about where we're at, okay? So we've spent a ton of time, or so it seems, working on user requirements, right? We went back and back and back to the user to get their user stories. Once we have the user stories, we said, well, great, these user stories are written in the language of the customer, which is good, okay, so we found that. But this isn't going to be quite good enough for our software developers to use. So we took a look at the user stories and we said, how about we go ahead and chop those up into tasks? So we created tasks, and a whole bunch of tasks equal one user story. So we're pretty comfortable with that sort of stuff like that. Now we had estimates for our user story, which is good, because we like to get started and stuff like that. When we broke everything up into tasks, we said, let's take a look at the tasks now, which are a little bit closer related to what we're actually going to be developing for our software, and let's come up with a new set of estimates for those tasks. Fantastic, so we got that one taken care of. We said, well, we got to sort of schedule this stuff. We got a plan for actually implementing stuff. We can't just put it all on the table and say, do it. So we came up with the concept of an iteration, and our iterations are how long? About a month, which comes down to how many working days? About 20, once again, this is all just, sort of rule of thumb. So about 20 days. So we look at our 20 days. Now, admittedly, all user stories are not created the same, so we went ahead and we prioritize them, right? So we said, okay, great, so we want to do the most important ones first, we'll do the least important ones later on. So we started with the most important ones, that was great. So we laid it into our little iteration thing, we used up the 20 days that was available. We got to the 20 days, poof, we were done with that iteration. We started pouring everything into the next iteration, and so on and so on and so on. So good stuff, we're very happy with this. We talked about testing, and we talked about all those other sorts of really great things that we're doing. Fantastic. Now, this is good. Yeah, I think we're comfortable with what we have to do to get started. Hopefully we're sort of comfortable with what we have to do while we're actually doing the software development part. The one part we really haven't talked about yet is, of course, what the heck do you do when you get to the end? Well, you have a party, of course. I mean, goodness gracious. You better wait till after this the party. But perhaps there's a little bit more than just having a party. The answer is yes, of course there is. And perhaps today, we'll just take a little bit of an investigative approach and find out what do you do when you end an iteration. All right. So where do we stand? So we've got our user stories and our tasks. We laid all that stuff out. We put it into iterations. The software developers have been working on it. Hopefully that's now all taken care of. Okay? Software development team has been working very, very hard. And so what do we have to do next? Well, one of the interesting things is, remember, this iteration thing that we put together, it was just a guess. It was just an estimate, and it was based on estimates, which were just guesses themselves. So this is not necessarily how everything's going to work out. I told you something was going to take 10 days, maybe it only took 8 days. I told you something was going to take 5 days, maybe it took like an hour. All sorts of interesting. By the way, I told you something was going to take 10 days, maybe it took 20 days. Right? You can go either way on this one. But it's entirely possible that we might have some extra time. Okay? Time that we got done early, which is great. But the question is, if that happens, what do we do with that extra time? It's really valuable. We've got to come up with a way to spend it correctly. How can we fit user testing in? Remember, user testing is what? Is it white, gray, or black box testing? Black box, right? Remember, users got no clue as to what's going on in your code. They don't know how you built it. They don't know how you put it together. But man, we really would like to do some user testing. Basically, give it to a sample set of some users and say, use it. Does it work? Is this what you were expecting? Right? Get their feedback as early as possible, right? Can we do more refactoring or redesign? Now, refactoring is one of those magical, fancy words you'll see every once in a while. Refactoring simply means I have perfectly good working code. It works for me. But I'm smarter now than I was when I wrote it. So I would like to go back and change that code. Maybe I'm going to make it smaller. Maybe I'm going to make it use different things. I'm going to make it better, quicker, faster. Okay? When I get done with it, it should work just as well, if not better, than it does now. I can't break it. That's sort of taking a step backwards. But it is definitely making it better. And perhaps all I'm doing is making it so it's easier to maintain that code. There'd be a heck of a lot of value to that. Okay? But that's you can only do that if you got everything else done. Because remember, that code's working. You can just leave it the way it is and life will be great. And then of course, bugs. Every time you crank out code, as you well know from your homeworks, when you first create your homework, it contains not just one bug, but probably a whole bunch of bugs, right? And some of the time you gotta go fix some bugs. right? You're not really done until those are taken care of. And the challenge that we have is that all of our planning, all the things that we've been talking about, have all dealt with new features, putting brand shiny new features into the code, which is great, but unfortunately it has nothing to do with fixing stuff. So that's a huge issue. All right. So this was our software development dashboard. Do you remember how this was? So we started with all of our user stories over here, and then one by one we moved them over to in progress when we were actually working on them, and that was really great and wonderful and stuff like that. And then as we got our tasks done for each user story, we moved them over here to complete. Eventually, of course, we get our entire user story done. At that point in time, we moved it down to our completed section. During the project, we had a burn down chart, and we would track how we were doing on that one. If there were any tasks that for whatever reason we decided not to do halfway through, we move them over into the next section so we wouldn't forget about them for the next time. And we even had this little section down here just in case there was any surprises that showed up. Like the boss showed up and told us we couldn't leave at the last minute. Of course, the boss would be left to do that. There would be no problem. Let's go ahead and put it here, and then we'll work it into what we're doing, okay? But anyway, we're at the end of the project, so hopefully what that means is that all of our stuff is now down here in the lower right-hand corner. And so we've gotten all that stuff taken care of. Okay, so what have we accomplished? Well, we've implemented customer-driven functionality, and we know that we have that because the way we did our software development process is we talked with our customer a lot, right? And unlike the waterfall method where we get our requirements, we go off and we hide in the closet for a month and then show up with some magical code that may or may not be what they want, we've been in a constant dialogue with our customer at the end of each iteration, right? We'd show them what we had created, we'd present it to them, we'd get their feedback and they'd say, yes, no, change this, oh hey, I've reprioritized, whatever we would say, something like that. So we're pretty comfortable with that. Next two items are compiling code and monitoring builds, okay? Because of the way we've set things up, we came up with a software repository, remember, and a software configuration tool, where people check code out, they make their changes, and then they check their code back in and stuff like that. We also have this concept where we're always compiling it as they check it back in. If they have stinky bad code, we should catch that right off the bat. So we're comfortable that all the code in our library is good code and good files. We've continuously tested the code. Remember we talked about design-based testing and things like that. So we have a great set of test cases for our code. Lots of them, fantastic. So we're reasonably confident that the code does what we want it to do. Okay. Most importantly, we feel that we have solid test coverage, which means it's not so much the number of test cases we have, but how much of our code is actually covered by the test cases. Remember, just rule of thumb, we're looking for what, maybe 85 to 90% of the code having test cases for it. And finally, we get down to reliable process tracking, and that's basically all the different things that we've been doing. It's repeatable, we can do it for each and every single iteration that we do. And we've got pacing that adapts to the team, which is a fancy way of saying that we have a velocity value that's calculated specifically for our team. We know how productive our team is, and so we're not going to ask them to do more than we believe that they can actually get done. This is all pretty reasonable stuff. I think that's we're on a good track here. Now, here's the trick though. When we get done with an iteration, there's a whole bunch of stuff that we would love to be able to do, but more often than not, for a variety of reasons, A, we don't have time, or B, we just forget that these are things that we want to do. We don't have a chance to get around to do these. Process improvements. So we have a way of doing things, and that's great and that's fabulous, but it's probably not perfect. We could actually probably do a better job. But the only way we're going to figure out what that better job is if we sit down and we have a discussion among ourselves and we ask ourselves, so, this time out, what worked and what didn't work? What could we have done better? Where did we have some communication flaws, et cetera, et cetera, et cetera. System testing, you can never do enough system testing. The challenge when we're doing software development the way that we're doing it though is, remember, we get to the end of an iteration and we start the next iteration. And we get to the end of an iteration, there's no system testing time really built into that particular process. Refactoring of the code using lessons learned, always a good thing to do. There's no question about that. It's just a matter of finding the time that it's going to take. Because remember the trick with refactoring, although it's a good thing to do, no question about that whatsoever, as a customer, I'm going to see no tangible benefit from you spending time doing refactoring. Remember, the code works. Now you refactored it. Oh, look, the code works. Great. I don't see any real advantage from you doing that. There is, of course, we know because we're bright, smart software developers, right? We know the code that comes out of your refactoring effort is easier to maintain. Maybe it runs quicker, better, faster. Maybe it's more efficient. Maybe it uses fancy new libraries. A whole bunch of interesting things like that, but your customer will never see that. Code cleanup and documentation updates. Oh, documentation. Yeah, I forgot about that. What a pain in the patooties, right? That's like a lot of writing, I think, okay? But if you don't have documentation for your code, how can you ever expect anybody else to ever understand what it does? Development environment updates. You know, you are developing your code in an environment. You could have a GUI system to actually create the code. You could have a set of libraries that you store someplace. You could have a set of reference tables. You could have a whole bunch of interesting things that you, as a software developer, use when you're creating your code. Fantastic. Things change, things get better, new versions show up. You've got to update your environment every so often. You really don't want to do it in the middle of an iteration, because if you break something or screw it up, then you're just toast, and all of a sudden that iteration starts to fall away. So you want to do it at the end of an iteration, where you're going to have to find the time to be able to do that. Okay, research and development on new technologies being considered. Where I work, one of the things that we're taking a look at right now is something called JNode, which is a set of libraries that you can use to create JavaScript quicker, better, and faster, and stuff like that. Great technology. Should we use it? Don't know. But I need to have my technical folks take a peek at it. Folks who understand the code that we're developing today, the folks who can understand what kind of code you can develop with JNode, and they're able to come back and say, hey, listen, this would help us do things faster, or this is just going to make life more complex. There's no reason for us to go down this path. Great questions, but you can only answer them when you've had enough time to sit down and take a look at the technology. And then, of course, personal development time. Look, you're a software developer. That's great. That's wonderful. You probably want to go up the management chain. You want to be able to do more things with your career. Where are you going to get those skills, right? You got to go to classes or training or something like that. How to be a manager, how to do time cards, how to motivate people, how to deal with really angry people, et cetera, et cetera, et cetera. So those are all good things that you need to do, but you just have to find the time to do it. If you're right in the middle of an iteration, that's probably not the best time. So a zillion and one things that you could do at the end of an iteration. The question is just which one should you do and how should you prioritize? All right, well, one of the things that we can all probably agree on is that system testing is really, really important. So system testing. What is system testing? Well, system testing is basically when you have a system to test, right? So you've used your skills and talents to create your portion of the software, which is great. There's maybe another 5 or 10 or 100 other developers out there who did exactly the same thing. So there's up to 100 different pieces of the software that eventually in the end all come together and create the system, right? In our case, it was an ordering and reservation system for a shack that was in the middle of a pond on a lake, right? Okay, so you need to have a system, and once you have a system, you need to test it to make sure that it works. That means you're going to have to allocate some time in your schedule to allow people to actually use this fantastic and wonderful piece of software that you've created, and have them run through and make sure that the darn thing does what it's actually supposed to do. To the best of your knowledge, yeah, it does, but you can only speak to that portion of the software that you created. Right? And that's the trick with system testing. System testing tests the whole thing from end to end. You need to let real users work on the system. You really want to let people who are going to eventually use the system test your system, because they'll use it in a way that they plan on using it, which might be different from the way you, as a smart bright developer, would use it. Okay? If they're going to break it, they'll break it right off the bat. You want to test the system in a situation as close to real world as possible, which means you want your users putting in real world data. Okay? You can come up with all the test data in the world we want. That's fantastic. That's wonderful. But until you actually have real users hammering on the system, putting in real world data, you won't know if the system's going to operate correctly once it gets out in the wild. Okay? And ultimately, it comes down to this. Okay, system testing is all about reality. Can your software survive in the real world? Or have you created some sort of delicate beast that can only exist in the lab environment where nothing bad ever happens to it, right? Okay? You want to make sure that the system works as a complete whole, not just your part. Yes, I understand the plane crash. You can't go back to the bad. but my in-flight entertainment system that allows users to select up to 16 different movies, at one point it was working just fine. Up until the last minute, they could select whatever movie they wanted. Well, congrats, they're playing so bad. Okay, so who does this magical, mythical system testing? Good question, okay? Okay, unit testing is something hopefully that you've been doing all the way along, and that allows you to ensure that the software that you were actually creating works fine. So we're comfortable with that. You did a good job on your system testing. Congratulations. Your little nugget of code is great, okay? Unit testing, however, can miss the bugs that only show up when we plug things together. Remember, your software has to talk to other people's software, right? You think that you've done that correctly. They probably think they've done that correctly. But until we actually put them together, we can't actually say that you're adequately communicating with the other guy. You thought that if you set this to true, he would take this action. He thought that if it was false, he would, whatever. He did complicate very quickly. Okay, system testing hooks everything together, treats the system like a black box. Right? We're comfortable with black box testing because we have no idea what's going on inside. The goal is to test the functionality that the user expects. So you would expect a testing person to show up with a big book of basically user stories, right? They don't care about your tasks and all the little things you broke it down into so you can do your software development. The only thing they care about is what they were paying you to do. Develop a system that allows me to order or place a reservation for my shack that's on the middle of a pond, okay? Make it so that I can get a DVD of the event, so I can pick my meals, so I can pick which bed I want to have in it, so that I can do a whole bunch of other things. Fantastic, that's wonderful. That's what I care about. I don't care about what database you use. I don't care about what GUI framework you used. I don't care about what hosting company you selected. All that stuff is yours to worry about. I just want to make sure the thing works, okay? System testing exercises functionality of the system from front to back using real-world black box scenarios. And the story there. Okay? You want to exercise the heck out of the thing, make sure that it operates correctly under all circumstances. So now it comes down to an awkward little question of who's actually going to do this ever so challenging system testing. Arguably, I would say this comes down to the size of your company. If you're working for a tiny little small company that only has a few people, you will pull every single warm body you get your hands on to do system testing, no matter what their day job is, right? However, if you work for a slightly larger organization, you would hope that you'd actually have testers or people who are dedicated to doing nothing but testing. If your developers end up doing the testing, you have a few challenges. The first one is the fact that they're too smart, right? Your developers actually worked on either this code or another piece of code that works with this particular code. And so they know how the system works. When they're doing their testing, they're going to come in with a preset set of expectations. I know what happens when I make that function call. I know what I should be seeing on the screen. And if I see something that looks close to it, I'm going to say it works, okay? They know how things work underneath the covers. They know the database and all the frameworks that are involved. And it's very, very hard for a developer to actually put themselves into the role of the user. They know what the input field should look like, so they provide input that looks like the input field is expecting. They can't do the crazy things that potentially a user would be doing, okay? However, if you use a tester, testers are much better, coincidentally, at doing testing, thus the name, right? Okay? So testers bring a fresh perspective, which might be the perspective of ignorance, right? They don't know how the thing was created. They don't know how you put it together. They don't know the challenges you had in interfacing to other people's software. And more importantly, they really don't care, okay? What they do know is they've got a stack of user stories that says what your code is supposed to be doing, and you're going to start testing from that. Testers are trying to find bugs. They get up in the morning trying to find bugs, they eat lunch trying to find bugs, and they go to bed at night only happy if they found bugs during that particular day. So when they're running the software, they're thinking, okay, so it seems to work pretty well now. How could I break this software? All right? Can I give it funky values? Can I, pull the dongle out halfway through the loading process? What can I do to cause the thing to fall over and just crash? And they will do everything they possibly can. Ultimately, they just want the system to work. They just want the system to do what the customer is expecting it to do. The one thing that you never really want to do is you don't want to test your own code. Okay? You are way too intimate with your own code. you know how it works, you know why it works, you know exactly how you're doing everything, you're no good at testing because you will only test the things that you expect it to do. So you always have to get somebody else to test your code. Now, of course, you do need a system to test, right? During the development cycle, you didn't really have a testing system to work on. What you have is a whole bunch of little pieces of software that hopefully everybody was developing unit tests on. Great, that's wonderful, that's fabulous, that's good. Okay, at the tail end, finally you had all these individually tested pieces of software that can then come together and you can then create a system at that point in time. Fantastic, that's wonderful, that's exactly what you want. You won't necessarily have extra days in your iteration for testing, which becomes a little bit of a challenge. You won't have a system to test until the tail end. The minimum requirements is that the system does need to be tested at the end of each iteration. Okay? You have to do system testing step by step. System will not necessarily have all of its functionality, especially after the end of iteration 1 or 2, right? You've only implemented some stuff. In our shack in the pond, let's see, what did we implement in the first iteration? Paying with Visa, MasterCard, and PayPal, and then also supporting up to 3,000 users. I think those were the 2 features that we implemented. You can test other stuff, but it ain't going to be there, right? Okay, so those are the only 2 pieces of functionality you can test in our system after iteration 1. Some user stories will be complete, can be tested. So those 2 that we just talked about, the paying, using the 3 different methods, and also the ability to support a whole bunch of users, you could actually create test cases for that. How to actually do this testing while development's going on. See, now that's the trick, okay? So I'm going to do system testing. Okay, great, that's wonderful. Should I stop doing development while the testing is going on? And the answer is, look, it comes down to the number of people that you have. But ideally, no. You need to keep developing, you need to start that next iteration. So how's that actually going to work? Well, your software developers are going to be working on iteration 1. Well, that's fantastic. Meanwhile, your testers could be getting ready to test iteration 1, which means they're reading the user stories and they're understanding what kind of tests they can develop. Now, when iteration 1 is done, yay, now you have a system that you can actually start to test on. So that's exactly what happens. You move iteration 1 over here, and the system testers start to test it. Meanwhile, back in the world of software developers, they're working on iteration 2. Now, when they reach the end of iteration 2, which of course is a month later, you need to have your testers done testing iteration number 1. That means all the bugs and all the errors that they found then goes into when the software developers work into iteration 3. Meanwhile, iteration 2 gets moved over into the testing environment, and now the testers start working on iteration 3. Okay, iteration 3 gets done. Now what you probably want to do is have your software developers take a break for an iteration and focus on nothing but fixing bugs, because you've actually got 2 sets of bugs that are going to pass on to them. Meanwhile, testers can be working on testing iteration number 3. Okay, so what we got going on here? Iterations allow the development team to stay focused. Okay, so they're looking at pretty much 1 or 2 releases behind where the software developers are right now. It provides checkpoints with the customer. So every time we hit one of these, we can tell the customer, yes, we're done, we're finished, and we've tested it. Okay, so that's good news for the customer. You need the same things for good system testing each and every single time. And the concept is if you get 2 cycles going, and you can stay in lockstep, and you can actually make a great deal of progress. When the test team signs off on the code, and you can say, listen, I'm done developing this code. Does this make sense? Okay, it does require a lot of bodies, right? I have effectively 2 parallel teams. One team is doing software development, and the other team is actually doing testing. And you can get crazy, and you can switch the teams back and forth if they had interchangeable sets of skills, but that doesn't really happen very often. Okay, more iterations means that you're going to have more problems. You know, we've talked about multiple iterations, iteration 1, iteration 2, iteration 3. Whenever you start having a whole bunch of iterations, you're going to start to have the introduction of some challenges for the teams that are actually involved in doing this stuff. The number 1 problem you're going to have is what we call communication problems, right? So look, you've got a testing team and you've got a software development team, and never shall the 2 talk to each other. I do testing, I do software development, I have no reason to talk to you. But really, you do need to have them talk, okay? The problem is that the testing team is going to have questions about the code that they're testing. But remember, what are they actually testing? So they're testing build 1, with the software development team is working on iteration 2. Do you think the software development team wants to talk to them about stinky old software? Absolutely not. So that becomes a problem. A lot of different ways to address this particular issue, but one way that works actually very, very well is if you start to bring people from your software testing team into the meetings that you're having with your software development team. We're talking about their challenges and what they're working on and what the schedule is and how they're doing and stuff like that. If you have a software testing person involved in that, they can collect all that information and they can take it back to the rest of the software testing team. But it helps you get that communication pathway flowing. Got a limited amount of time available for testing. So this is an interesting point. How? Here's a gigantic piece of software. Go ahead and test it. Oh, okay, thank you very much. Well, by the way, you've got 30 days, right? Because we've told those testing people they have to get done with testing this version of the software by the time the next version of software becomes available, which means they've only got 30 days to test the whole thing top to bottom. So that can get tricky, okay? So we have to keep our iterations in sync, okay? We have to force the testing into a limited amount of time, roughly about 30 days or so, which is interesting because now maybe what we actually need to do, we're getting development estimates for each user story. Maybe we need to get testing estimates for each story too. How long is it going to take you to test pay with MasterCard, pay with Visa, and pay with PayPal, right? To work that into exactly what we think we can get done in a given iteration, okay? And those estimates might show us if we have any problems. You know, if I have something that's going to take me 5 days to develop, but 20 days to test, clearly something's a little bit out of whack there. We're going to need to chop that up more. Okay, fixing bugs while developing new code. Development team gets bug reports on the first iteration while they're working on the third iteration. Really? Okay, and you may have completely changed your code, right? You may have changed everything in your code, and now you're getting a bug report about something that doesn't even exist anymore. Okay? Every time you get a bug report, you have to make one of 3 different decisions. Are you going to fix it right now? That's a huge problem. The code does not work. We can better get moving on that right now. Okay? Or we're going to fix it in the next version. Okay, hey, it's an issue. Okay? But there's no workaround. It's not going to stop the user from doing stuff. We'll fix it in the next version of the code that we're going to have. Or are we going to put it off for later on? Yeah, it's a problem, but nobody's ever going to do that. Okay, that's not very common. I don't think that's going to be a big deal whatsoever. We'll fix it someday. Got it. You feed each bug like a new user story, makes sense, okay, and then prioritize it accordingly. So if it's a user story and we're prioritizing our user stories, it'll get caught up in that, and we'll figure out how, we'll have the user figure out exactly when we should end up doing it. There's an alternative. We can save time during each iteration to work on bugs. So, you know, we figured out we had, what, 20 days in an iteration, which is cool. We then took a look at our features and we tried to get our features to work out to be 20 days worth of development time. Maybe we should only try to fill up 15 days with development and say, listen, we've got 5 days at the tail end that we've reserved just for fixing bugs. Right? Sounds like you could slap out an awful lot of bugs if you did that. Okay? Dealing with the moving target, this is a huge issue because, once again, the user can be changing their mind literally every single day, right? So the testing team struggles with that just as much as the software development team does. Functionality changes, it can really frustrate the testing team. The key here is communication. Look, your customer can change their mind anytime they want. You can't stop them from doing that. But what you can do is, based on your conversations with the customer, when you think that there's a possibility the customer might be thinking about changing their mind on something, at that point in time, you need to go back to the team and communicate to them and say, listen, I don't actually know that there's any changes coming, but there's a good possibility the customer might end up changing something here. What that's going to allow your team to do is, if they haven't actually implemented that feature or function now, maybe they push it off for a little bit and do something else, okay? Then if the customer changes their mind on that, they don't have to go back to the user anymore, okay? So you gave them a little bit of a heads up and it was very useful for them. Make sure the testing team knows that a change may occur also, of course. More iterations means more communication. That's the short story here, right? You've got, whenever you're doing software over and over again, and you've got a lot of different teams, testing teams, software development teams involved, the key thing is going to be to make sure that everybody's talking to everybody else. You will have messy issues. You've got a bunch of teams, you've got changing requirements, you've got incomplete requirements. These aren't clean, well-defined problems. These are messy, sloppy sort of problems. Okay? You start working to that, the confusion of multiple cycles, that means you're going to have more and more of the same issues. The good news is no new issues. The bad news is, hey, I've seen all these issues before, we had them in the past iterations, right? You need to use all the tools that we've been talking about to stay in touch with the development team and the testing team. So you have to talk to both teams, and you have to make sure that both teams are talking to each other. Key to solving most of the problems that you'll ever run into in the software development effort is communication. Making sure that everybody has the same view of what's being done. Okay, so what did we cover today? Talking about system testing. It's important. You need to do it. The challenge we have with system testing is that you actually need to have a system to test, right? You don't have a system to test until you get to the end of an iteration, and all too often we don't build any time into an iteration to do enough for any system testing. We talked about a whole bunch of iteration problems because you've got multiple teams, you've got testing teams and software development teams, you've got communication problems coming out below, you've got all sorts of interesting things going on. But the good news about that is, number one, we realize that they exist, okay, so we're cool with that. And number two, there's a solution for every single one of them. All right? Fabulous. So that's what we covered today. Whatever shall we cover next time? Editing iteration part 2. There's more to this stuff. Oh my God, really? Yeah. Well, an interesting thing is when you end one iteration, what are you going to do next? So it seems like you should be doing some stuff to get you ready. Okay, we'll talk about that next time. Fantastic, wonderful. We're going to be talking about some functions here in just a moment. Why don't we take a break and come back at 5 after.